Hello and welcome to Physics Doctor. My name is Dr. Ghanshyam Tejani and let's start class 11, chapter number 3, motion in a straight line, and the similar content it is there in JEE NEET unit number 2, kinematics. And this is our session number 6 and what are our learning agendas. So we are targeting first, that is instantaneous velocity, and second is instantaneous acceleration. And how are we going to learn this? By solving various examples from the NEET, JEE, and JEE advanced question. And this is the best method. Believe me, this is the best method to learn a subject like physics. Starting with, what is instantaneous velocity? You might wonder, this is something a new word to you, might be, but before that we already studied one thing, that is average. We know that what is average velocity. What is average velocity? We know it very well. Let us understand once again to have a deeper knowledge of the subject. Let us draw x and y coordinates, and along the coordinate which is x-axis, let us take time, and along the y coordinates let us take distance. And say for example, there is some relation with x and t. Say for example, this line is showing relation between x and t, means x is increasing with t. Fine, that we already know. And here x is showing displacement, t is showing time. And if we want to have a and b average velocity, what is the average velocity from position A to B? If we wanted to have this data, we know it's very simple. How? We can extend this point to the reference axis, so it gives us x1. Similarly for the B reference axis, it gives x2. On the vertical line, it gives t1 time t1 and time t2. We know that, and we know that if you wanted to have velocity, that means this gives x2 minus x1 divided by t2 minus t1. We know that very well. And in other words, we can write change of displacement delta x in general divided by delta t. That we know this is known as average velocity. This is known as average velocity. Now see, in this case, if we see this is having a straight line, then therefore velocity is a constant throughout this graph. Velocity is constant throughout this graph. And if we take slope, if we just wanted to have slope, let's have another name C, the horizontal line. Let's assume horizontal line. And we know that slope m is equal to opposite side perpendicular side divided by nearer side, and is equal to similar x2 minus x1 divided by t2 minus t1 is equal to delta x by delta t. And therefore slope is velocity. When we plot a graph x versus t, slope gives us velocity. Remember this word, slope gives us velocity. When we perform x versus displacement versus time graph, slope gives us velocity. We will again understand this at a time of graph understanding or graph evaluation, right? But now this is very much important for that. So now, if some cases, suppose in the case of certain, if you draw similar graph for certain other object x versus t, and if this is the graph, it is not a straight line, but it is somewhat increasing with a time. So in this case, velocity is not constant. Let's just check how it is not constant. Say for example, this time let us assume is equal to 1 second, and for that it is taking distance. It is taking, say for example, 1 meter. So what is velocity? Velocity is equal to 1 by 1 is equal to 1 meter per second for this region. For this region from point A to B. Let us assume other similar point distance 1 second, after 1 second, after 1 second, it is reaching somewhere here. And if we see this length height, so approximate 5 meter. Approximate 5 meter, right? So for the first instant, but for the velocity for the second instant, it is 5 divided by 1 meter per second is equal to 5 meter per second, right? So if we see clearly, we can see here clearly the first instant v1 approximate from this region velocity, average velocity, it was 1 meter per second, but here at point some other point it become 5 meter per second. Therefore, whenever there is a curvature, velocity is not constant, right? And therefore instantaneous velocity is required. Say for example, at particular this point, at this point, what is velocity? If I want to know at very small time, of course displacement will also be very small, and at that time if you wanted to know, we cannot use this equation of average equation. We have to have some different equation. Let's see how it works. So what is instantaneous velocity? The instantaneous velocity is the velocity at a particular instant of a time. It is for a very small interval of time. If you see here, it is a graph, displacement versus time graph is given, and if there is some curvature, and if I wanted to have average velocity between A and B, so we know that average velocity is equal to x2 minus x1 divided by t2 minus t1 is equal to capital delta x divided by capital delta t. That we know very well is equal to slope. This AB is representing a slope. But if I wanted to have a velocity, instantaneous velocity for very small t, we can show by dt. So for that very small t, of course displacement will be also very small, dx. And for this very small region, if we draw a tangent, and if we identify slope of this tangent, the slope of this tangent gives us instantaneous velocity. So we know it is equal to what? Dx by delta t. How we can do it? So our velocity is equal to limit, and we know that when delta t tends to 0, delta s, or you can write delta x also divided by delta t when it tends to 0. So just we write ds, which represent a small distance, and dt represents small d. So this is mathematically we can do it. See, if we want to find for this instance, say for example, I want to have what is velocity of this. So what I can do? I can do a tangent. I can draw a tangent, and then you can measure this theta. You can take this height and this width, and you can take tan theta is equal to h by v, and that is a v velocity, and from that you can draw, right? I think for the graphical representation it is taking too much time, and therefore mathematics works here. Mathematical is grown, and at that time we just need to have ds by dt and the problem will be solved. So similar cases here mentioned when the t2 approaches towards t1. So when t2 approaches towards t1, right, b approaches, right, this is the distance is showing, and the core AB, the distance between AB, right, become tangent to the curve. So we already seen this part. This AB line become tangent to the curve. when it is very small, and the slope of tangent, it gives velocity. We already seen for the average velocity, slope is giving tangent, and here also tangent is our slope, it is giving time. So this is the equation is useful here. V is equal to ds by dt. And similar to instantaneous acceleration, it is also similarly defined. A is equal to limit t delta v by t. So here just we need to have v with respect to t. Thus that graph is required, dv by dt, and that gives us instantaneous acceleration. So this is something about instantaneous velocity and instantaneous acceleration and how this works. Let us go into deeper. Solving the first example. Example number 1. Here you can see there is some differentiation formula it is given. The reason is that in this chapter you need differentiation as well as integration. So I suggest that I will put videos on differentiation as well as integration. So you refer that video here. Majorly we need a very small, very easy differentiation. So first is put in, suppose d by dx u power n it is given. So you just need to just take n just in front of u and that become u n minus 1. You can see here again, if it is u power n, so it become n, just take forward n and just n minus 1. That is become differentiation, very simple. And if it is not here x, that means you will also have du by dx. Suppose if the equation it is like that, d by dx and here x power n, so in this case just n x power n minus 1. This is your solution. dx by dx become 1, so it is not required. So you need to understand this equation. So example 1 is given, the position of the particle moving along x is given by x is equal to 2t minus 3t square plus t cube, where x is in meter, t is in second. What we need to find the velocity of the particle, t is equal to 2 seconds. So first we need to find velocity, but here displacement is given, and second is find the average speed. Let us just start with 1. See here x is given and we know that dx by dt which gives us velocity. So what are we waiting for? V is equal to dx by dt, or you can write ds by dt, whatever you love. Let's do differentiation of this equation. So here 2 t power 1. What about t power 1? d by dt t power 1. So power 1 should come forward. So 1 t 1 minus 1 is equal to 0. So it is just 1. So is equal to 2 multiplied by 1. Minus other component is given. Let's solve it. What is given? 3t power 2. If you just want to have d by dt, so 3 is constant, you can keep outside. T, so 2 should be in the front. 2 t power 1. So become 6t. And the last portion, it is t power 3. If you just want to d by dx, so it becomes 3 t power 2. You just take this power in the forward direction and just take it minus 1. So it is very simple. So here 2 minus 6 plus 3t. Now what we need? Find the velocity at t is equal to t. So here just at t is equal to t, what is v? V is equal to 2 minus 6 2 plus 3 t square. T is equal to 2. Put this value here. 2 minus 12 plus 12. So is equal to 2. Answer is 2. So V and V is equal to 2. So first answer we got. Velocity is also 2 meter per second. Fine. Second is find the average speed. Here it is mentioned average speed. So you cannot take dv. Average speed is equal to delta x by delta t. Therefore, is equal to x2 minus x1 divided by t2 minus t2 minus t1. So here we need x1 as well as x2, t2 as well as t2. So x1 is given, x1 is equal to t is equal to 2 second. Put this value, this is the equation we have to use now. 2t minus 3t square plus 2 power 3. So x1 is equal to 0 meter. And if you wanted to x2, so first is t is equal to 2, second is t is equal to 4. Let's put x2 t is equal to, here it should be 4 second, put the 4 here, 4 4 4, and x2 become 24, x2 become 24. Now we have all the values. V is equal to delta x by t. So 24, x2 is 24, x1 is 0, time is 4 minus 2, become 2. So velocity is equal to 12 meter per second. This is our solution. Let's move. Example number 2. I simply suggest that you pause the video here, solve this equation by yourself, and then only you should just tell your method and answer. If you really want to learn, always solve the video. Do not just watch video. Solve the question. A video, how can you solve? So it is mentioned the displacement x in meter of a body varies with time in second. X, the equation is very important here. X is equal to minus 2 by 3 t square plus 16t plus 2. How long does the body take come to rest? Right. So here body is having some movement. It is moving, and at some place it is resting. So distance, it is somewhere it is resting. So velocity becomes 0. Then we need to find the distance. You need to find the distance. So if you wanted to have distance, instantaneous velocity becomes 0. So what are we waiting for? X is given. What we should do? Velocity is equal to dx by dt. And if it is come to rest, means velocity is 0. Put the value here. Differentiation of minus 2 by 3t square. So differentiation minus 2 multiplied by 2 by 3 t power 1. So it is 4 by 3 t. 16t become only 16 and it becomes 0. This becomes 0. This becomes 0. Put this value here. So here minus 4 by 3t. So we can write minus 4 by 3t is equal to 16. You can divide this, so become 4. T is equal to 4 multiplied by 3 is equal to 12 second. 12 second is our correct answer. Another example. Displacement time equation of a particle moving. Yeah, that is just a story. Here equation starts. X is equal to 20t cube minus 12t. Find the position. That means position at time is equal to 0. So you can directly put here position time is equal to 0, this 0, this 0, position x is equal to 20. So first one is very simple, but velocity also we require. So to find velocity, I think you should pose, and this is very simple question. You solve it. Velocity is equal to dx by dt. Put the value here. So 20 becomes 0. This becomes 3t square and this becomes minus 12. It is mentioned here. Put t is equal to 0. Put t is equal to 0. So velocity here it becomes 0. Velocity is equal to minus 12. Minus 12. Is it meter? Meter per second. It should be meter per second. How can you make this mistake? So this is example number 4. You should pause the video. Do not play until you get your answer. So here it is given for a particle moving along x-axis. Displacement, this equation is given. Again, the same equation is given. Find the position and velocity of the particle at time t. So if you see here, first portion is very similar. So here equation is given. X is equal to 20 plus t cube minus 12t. So here the differentiation gives us velocity 20 becomes 0, here becomes 3t square and here becomes. Put t is equal to 0, we can find x is equal to 20 meter and velocity is equal to minus 12. This already we have done. So one is not difficult. Find out whether the motion is uniformly accelerated or not. So here it is asked that acceleration, whether it is uniform or not. If see acceleration, if it gives constant value, then only we can say acceleration is uniform, otherwise it is not. So let us find acceleration. What is equation of acceleration? A is equal to v dv by dt. Do we have? We have v. Can we differentiate this? Yes, of course we can differentiate it, and this become differentiation becomes 6t and this becomes 0, so it is equal to 6t. That means acceleration is not constant but is equal to 6t. It is not constant. Acceleration is increasing with 6 times t. Suppose if t is equal to 1, acceleration is equal to 6. So at t is equal to 2, acceleration is equal to 12. So it is increasing. It is not uniform. Right. So it is non-uniform acceleration. Acceleration is not uniform. Then see, find out the position of particle when velocity is 0. So here it is asked that when velocity is equal to 0, we can put velocity is equal to 0 in this equation. So 3t square minus 12 is equal to 0. Can we put 3t square is equal to 12? We can divide this, so become 4 and t is equal to 2. Time cannot be negative, therefore time has to be positive answer and t. So find out the position at, so we got time is equal to t. We have position equation. Put here 2. So 20t cube minus 12t, put 2 here and answer is 4 meter. Answer is 4 meter. It is very simple. Next. Example number 5, the motion of a particle. Now you pause the video and do it by yourself. So particle, it is given motion, it is described by, it is just a story. So x is equal to 8 plus 12t minus t cube. Wow, x is meter, t is second. Retardation of the particle when its velocity becomes, that means the case is for the retardation and the velocity is given. So what we need to do, equation is given and the question was asked. Now it is NEET, but it was previously, it was All India pre-medical test that was asked in 2012. So we know that velocity is equal to dx by dt and is equal to 8 becomes 0 plus 12 becomes 12 minus 3t square. Differentiation, if you don't know differentiation, you learn it. So it is mentioned that when velocity becomes 0, so v is equal to 0, can we take 3t square is equal to 12, so t square is equal to 4, t is equal to 2, because only plus is possible for time cannot be negative. So t is equal to t. What we need to find? We need to find retardation. So we need acceleration. We know that acceleration is equal to dv divided by dt. Let's differentiate this. Let's differentiate this equation. This is velocity. This is velocity. 12 becomes 0 minus 3 becomes 6t. 6t. Put this value here, minus 6t. T is equal to t. So acceleration becomes 12 meter per second. Negative sign shows a deceleration. Therefore, answer D is correct. Isn't it very simple? I think it is very simple. Let's move towards somewhat difficult question number 6. Two car P and Q starts from a point. So let's draw cars. So this is a car number 1. Car number 1. The name is P. And another car. This is another car. This is Q. Moving in this direction. So They P and Q starts from the similar point. They starts motion from the similar point. At the same time, in a straight line, they both are moving in the straight line, and their positions are represented by. So it is the important part is xp is given. Xp, right, function of t. So is equal to at plus bt square. X is a function of t, and q is also function of t is equal to ft minus t. At what time do the car have same velocity? That means velocity of both the cars must be equal. We know velocity is equal to dx by dt. Velocity is equal to dx by dt. And now what? We need to just find velocities for both. We just need to have velocity of both. So v is equal to dx by dt. Can we differentiate this first? Yes. Here a t. So this gives a b t square. That t square is equal to 2t. So it becomes 2bt. Excellent. And similar here for velocity for the q car. So here f t is become f minus t square become 2t minus t square become 2t. Now what is mentioned here? Both are having similar velocity. NEET 2016. Put this, both the velocities are equal. Car have same velocity at the time. Vp is equal to Vq. Put Vp and Vq here. A plus 2bt is equal to f minus t. If we just send here, so what become 2bt plus 2. We can t as a common and opposite f minus a and become t is equal to f minus a divided by 2b plus 1. Do we have that question? F minus a, yes, it is here. And the similar answer number D is the correct answer. Answer number D is the correct answer. Great. Question number 7. Here you need some integration. Integration is required, therefore it is mentioned. So here, if it is integration like that x power n dx, integration is opposite of differentiation. So here, just take x is equal to n plus 1 and divided by the same power n plus 1. Again, if you want to integrate, so we need integration sign. This is for integration sign dx. So just x power n plus 1 divided by the power n plus 1. That gives us solution. That gives us its solution. And if integration is 1 by x of dx, so is equal to ln x. So these two are needed and therefore it is mentioned. Right? You learn all the types of integration, then only you can secure good marks. So example number 7 is given acceleration of an object moving in a straight line. Acceleration is given, equation is given, a is equal to v square and initial velocity of that object. So initial velocity is given u. Find v of x, that means see v function of x is given, that means on opposite side everything should be in the form of x plus something, x square, some constant, everything should be in the form of x. And second is we need to find v of t, that means it should be function of t. Right? Both are very different. Let's start the first one. What is given? A is equal to v square. And we know that velocity is equal to dx by dt, change of displacement divided by change of time. Acceleration is equal to dv by dt, that we know very well. Right? So here first case a is equal to v square is given. Right? So here a is equal to dv by dt, and we know that a is equal to v square is given. So we can write both is equal to v square. That is mentioned here. Very clearly. Right? But see, to derive this vx, we need x term there. We need to have x term there. So can we write dv by dt is equal to dv divided by dx multiplied by dx divided by dt? Yes, of course we can write. And what about this dx by dt? What about dx by dt? That become v. That become v. So we can take v inside, v dv by dx, v dv by dx. Similar here. So acceleration is equal to dv by dt. We can split this into dv by dx, dx by dt, and this dx by dt become v. And we need to write v here in the front side. It is better. So we can cancel out one. V can be cancelled out. Opposite become v. Opposite become v. Opposite become v. We just need to have one side should be all the v items and opposite side should be all x item. If we wanted to have an integration, then means both the sides should have one variable v and v. Now let us integrate both the sides. Let us do integration both the sides. So integration start with u initial. This is showing initial range and that is showing final range. Integration u to v. And the similar part it is here is equal to integration of 0 to x, right? It is mentioned that initial velocity is u and therefore final is v. Therefore, it is starting from u to v. And opposite is initially starting with 0 displacement and final is x displacement. Now, integration of 1 by v dv is equal to, see this 1 by x dx, so that becomes ln of x. So here it should be ln, then that is what ln, the variable is v, so it should be v, it should not be x but it should be v, fine. And we can write in the form of like mode u to v, its range is u to is equal to, if you see here it is dx means x power 0, x power 0 means what should be solution, x power 1 divided by 1, so become x. So is equal to x, again we need to show range 0 to x, 0 to x. So ultimately what is our answer? Ln v minus ln u is equal to x, x is equal to x. We can write ln v minus v, we know that it can be write v minus u ln. And if you wanted to have, we can have e power both, right? So v and u come outside and e power ln become 1 and therefore it gives v by u is equal to e power x. It is very known to us, and what we need velocity function, so v is equal to u power u of x, right? So here velocity function we already got in the form of x, so is equal to v of x is equal to u e power x. That is our answer. Now second is asked v function of t, v it is function of t. That means in this equation v should be in the function of t, and we know that a is equal to dv by dt. So here already t is available. Let's put here both the side, dv by v square is equal to dt, and we can put now taking integration of both the side, integration u to v dv by v square is equal to 0 to t. What is 1 by v square? What is 1 by v square? So we can write integration v power minus 2 dv. So we know that v minus 2 plus 1 divided by minus 2 plus 1. So become v power minus 1 divided by minus 1. Right. So minus 1 by v, it become minus 1 by v. And what about this? Opposite become t. It is very simple. Opposite is t, which is a very simple one. So we know that 1 by v minus 1 by u minus become plus is equal to t, and therefore v1 upon v, we can take v as a one side. So v is equal to u divided by 1 minus ut. That is very simple, don't you think? You should pause the video here and solve this example, I think. What is mentioned here? Velocity time equation for particle. So V, it is given here, V is equal to 10 plus 2t plus 3t square. It is velocity is now mentioned, not x. Fine. Find displacement. We need displacement of particle from the mean position at a time t is equal to 1 second if it is given that displacement 20 at t is equal to 0 second. See, this means what here? Displacement given x1 is equal to 20 meter at t is equal to 0, and we need to find t is equal to 1, x2, say for example, let's have x. So whenever the equation is given, v is equal to 10 2t plus 3t square, and we know that v is equal to dx by dt, v is equal to dx by dt. So we need equation of x, displacement, and therefore we can take dx at one side, dt at opposite side, so that become here. And now what? Now it's time for integration. Integration on both the sides are required. We can do integration, and here initial x is 20, final x it is x. Final x, it is the similar case it is given, and opposite side it is time. So 0 to 1. So opposite side what it become here? That become x. 20 to x is equal to 10 become 10t plus 2t square by 2 plus 3t cube by 3, and that will cancel out, right? And 0 to 1, 0 to 1. So that is our solution. You can compare with this. So here become x minus 20 is equal to 10, 1 plus 1 plus 1. So x is equal to 12 plus 20 is equal to 20, 32, 32, 32, 32, 32. Right, so answer is 32 meter. Answer is 32 meter. Example number 9, and it was asked in JEE 2019 mains examination. Right, pause the video and solve this example. I think you must have answered for that. So here x is given, x of t is given 𝑎𝑡 plus 𝑏𝑡 square minus ct cube, where a, b, c are constant. When particle attains zero acceleration, that means acceleration should be 0, then its velocity will be, right. So we need to have this equation is given, v is equal to dt by dx and a is equal to dv by dt. So first we need to differentiate this equation with respect to t, so we can get v. So how to differentiate this? It become at become a plus 2bt minus 3ct square. It is here. And again we need to have acceleration a is equal to a becomes 0, 2bt become 2b, and 3ct, so 2 should be outside, so 3 multiplied by 2, 6ct. Acceleration is 0, acceleration is 0, acceleration is 0. So here 2b is equal to 3ct and t is equal to 2b divided by 3c. It is 6, I think it is 6, right? So 2 is cancelled, 2 is cancelled, 2 is cancelled. Do not make such mistake. So now what we need velocity. So we have a time t, acceleration is 0, put the value here in terms of velocity. So v is equal to 2 here in the terms of time. So become 2b, this become 2b square divided by 3c minus 1c is cancelled. B square divided by 3c, so that become, right, it just become 1 is cancelled, fine. So a plus b square divided by 3c, this one is correct. No, this one is also not correct. C is correct. C is R. So the question was asked in JEE 2019 mains. Then example number 10, the velocity of particle v is equal to v0 plus gt plus ft square if its position x is equal to 0, t is equal to 0. then its displacement after unit time t is equal to 1. So first initial condition is given, x is 0 and t is 0, and we need to find t is equal to 1. Here velocity is given, so we need to convert this equation in terms of x. Otherwise, how can we solve this? Pause the video and solve this. V is equal to dx by dt. We all know that is equal to v0 plus gt plus ft square. What we should do now? T should be move here on the opposite side and then integrate. So it become integration 0 to x. We know that initial position is x and t. So 0 and x is final displacement. Dx is equal to 0 to 1. Time is given 1. You can put t is also in place of 1 and you can derive equation, and after that, after deriving equation, you can put t. Fine. Now, what is the value of dx? So it become x mod 0 to x. So become x minus 0. And opposite side, v0 t plus gt square by 2 plus ft cube by 3. We know that if it is x power n, if you wanted to have integration, so box become x power n plus 1 divided by n plus 1. Right? So that you need to remember. So we got this, put x is equal to 1, so become x, and here t is equal to 1. So x is equal to v0 plus g by t plus f by 3. And that is our answer. Very simple. Compare your answer with this. Oh, NEET 2016. The question was asked in NEET 2016. What is mentioned? Pause the video and solve this by yourself. Here it is mentioned, if the velocity of a particle v is equal to 𝑎𝑡 plus 𝑏𝑡 square, where a and b are constant, then the distance traveled by it between 1 second and 2 seconds, initial seconds are given. So distance is required, so velocity, we need to convert this into equation of distance. So v is equal to dx by dt. V is equal to dx by dt. Putting this value, dx by dt is equal to 𝑎𝑡 plus bt square, because v is given directly, v is given this one. So what next? You just put t on the opposite side. So dx is equal to 𝑎𝑡 plus bt square dt. Now what next? Take integration. Integration from x1 to x2, first position to next position, dx is equal to, see it is given, travel between 1 second to 2 seconds. Therefore it is here, it should be 1 second, and opposite it should be 2 seconds. Put this equation here. So what become here? Mod x x1 x2 range is equal to, here a t square divided by 2 plus b t cube divided by 3, 1 to 2. What next? You put the value here. This become x2 minus x1. That means delta x is equal to, here t is equal to 2. That become, right, you just have 2a, b, that become 8 by 3, and here it is 1 by 2. We can take this and find the final answer. So is equal to 3a by 2 plus 7b by 3. See, this one is incorrect. 3a by 2. Yes, b is correct. So you got full marks. NEET 2016. Let's move to the next question. Why not? Oh, there is a question. See, in the next question, you need some understanding of a straight line. We will take this full portion in a graph lecture, but let us understand now. Some feel should be there. A straight line. So we know that a linear relation between x and y represents straight line. Y is equal to mx plus c. Any of the line, if you want to represent, then equation is y is equal to mx plus c. Here y, that means vertical coordinate, and x, that means horizontal coordinate. And this line is represented by y is equal to mx plus c, where m is tan theta, and if with theta it is less than 90 degree, if it is less than this 90 degree, theta is with respect to x, so this becomes theta. So that means it is positive, m is positive, m is positive. And if theta is greater than 90 degree, that means m become negative. So we need this understanding. M is showing the slope and C is y intercept. That means when x is equal to 0, C presenting its y position. When x is equal to 0, C is showing position. Right. So slope, it is presented by tan theta, and we need this. So we need y is equal to mx plus c in the next equation, as well as we need here theta, where it should be positive, where it should be negative. So we know the m greater than 0 positive when theta is a smaller 90 degree, then less, and m is should be less than 0 negative. That means theta, if it is greater than 90, and theta always lies between 0 and 180. That we know it, right, very well. So question number 12, it is here. You should pause the video. This is a difficult question, but you should try by yourself. You may have some different method also. If you get the correct answer, you will have huge confidence. There will be huge boost with your confidence. So it is mentioned a particle starts from rest x is equal to 0. So initial x is given 0. Its acceleration at time t is equal to 0 is 5 meter per second square, which varies with time as shown in figure. See, so at time is equal to 0, acceleration is 5 meter per second. You can see there is a reduction in the acceleration, right? So there is a deceleration, and then when there is a time is 6 second, acceleration becomes 0 from the graph we can identify, right? So find the maximum speed of the particle and its displacement in the time interval at t is equal to 0 and t is equal to 2 seconds. See here, equation is not given. That's a sad problem. So we know that there is a straight line, and for that we know that equation y is equal to mx plus c. What is y-axis? Y-axis is this one, so y is equal to 1. What is x-axis? This one, so x is equal to t. That means we know that we can put here y is equal to a is equal to m. In the form of x, we can write t plus c, right? Then what next? M, here angle is theta, it is greater than 90 degree. That means it's a minus negative tan theta, and we know that tan theta perpendicular side, so minus 5 divided by nearer side 6. So m is equal to minus 5 by 6, and what c, when c is required. So we know that t is equal to 0, c is equal to a. T is equal to 0, c is equal to a. That means c is equal to 5. Put this value here. So y is equal to mx plus c. Here a is equal to y is a, t, x is t, m is tan theta, minus 5 by 6, c is equal to a is equal to 5. Put this all, a is equal to minus 5 by 6 t plus 5. And that equation you have to derive for this solution. Now we have, let's find the first maximum speed. That means we need to have maximum speed, we need to have velocity. So we know that acceleration is equal to dv by dt. So put this value here, and what next? dv is equal to, put this dt opposite side, integration is required. Integrating both the sides, so velocity, it is starting from 0 and matching at velocity v. Starting velocity is equal to c 0, but it is crossing at some velocity maximum, or maybe what? And time t is equal to 0, start with 0 and reaching some time t, or you can write 6 also, but generalized equation we can get from this. So now what is here? V, integration of V, 0 V is equal to integration of integration minus 5 by 6 t square by 2 plus 5 t 0 to t. So that become 12, that become 12, that become 12. You can compare with this V 0, put this value here, so it become V minus 5 by t square plus 5t. So this we got this equation, what is mentioned? The maximum speed of particle, see here there is a acceleration is maximum, and acceleration is equal to 0, right? So at acceleration 0 there is no again other force, or you can say it is not acceleration, it is a deceleration, means it is reducing speed at every time. That means at this point t is equal to 6 seconds, velocity must be maximum, So from the graph, t is equal to 6 second, velocity should be maximum. So put this value here, t is equal to 6. Put the value here, put the value here, and this is 15 meter per second is the maximum velocity. It is the maximum velocity. So first answer we got, the first answer is now available with us. Now second, it is displacement. We need to have displacement. Now what we got equation of V. Similar to that, we need displacement interval t is given 0 and 2. So time interval is given. So we know that V is equal to dx by dt, and equation we already have for the velocity. So what we can do, dx, we can put opposite side dt. Let us take integration on the both the side. So what we got? We got 0 to x, dx is equal to 0 to 2, and this is equation. So here it become x, 0 to x is equal to what next? Minus 5 by 12 t power 3 divided by 3 plus 5t square divided by 2, and mentioning from 0 to 2. Let's check it. So here it become x is equal to, put the value t is equal to 2. So minus 5 by 32, 2 cube plus 5 by 2 t power 2. So x is equal to 80 by 9. X is equal to 80 by 9 meter. Now example number 13. I think you should pause the video and solve this by yourself. So what is given? A particle is moving along x-axis with acceleration is given. A is equal to 2x, where a is in meter per second square, x is in meter. If the particle starts from x is equal to 1 meter, find its velocity. Acceleration is given, we need to find velocity v, we require v. When it reaches to position x is equal to 3, we need v. So a is equal to 2x is given, then we know a is equal to dv by dt. We can write dv by dx by dt. So what is dx by dt? dv by dx, and this is v. Right, so we can write here in this form. Then velocity is given. So let's prove is equal to 2x is equal to 2x. So our equation should be in the form of x. Because we need to convert this in the form of x only. Displacement we require. So velocity should be in the form of x, not it should be in the form of t. Right. So here integrating both the side with 0 to v, and this position is given 1 to 3. Opposite side is given 1 to 3. 2x divided by, so v become v square divided by 2. 0 to v is equal to 2x power 2 by 2. So 2 should be cancelled out. 1 2 3. So put here v squared by 2 is equal to 3 square minus 1 minus 1. Answer is v is equal to 4 meter per second. Answer is v is equal to 4 meter per second. Let's say one more question. I think you should pause the video here and solve by yourself. So example number 14, it is a particle initially at t is equal to 0. Initial condition is given t is 0. Moving with a velocity u is subjected to a retarding force, and because of that there is a retardation, and acceleration is given minus k under root v. There v is instantaneous velocity, k is constant, and the time taken by the particle to come to rest. So we need here time for that particle come to rest when velocity is 0. For this case, we need equation of velocity. Acceleration is given. We need equation of velocity for this case. And then find the distance the particle travels during this time. That means we need to have distance also. Means equation of x is also required. Let's find first equation for here velocity. So a is equal to minus k under root v. It is here given. We need first equation for the velocity. We need equation for the velocity. So a is equal to dv by dt. So we know that a is equal to minus k root v. So dv by dt is equal to minus k root v. What next? V should be same side. V root is equal to minus k dt. Right. Now what next? Integration. Both the side integration is required. We can integrate this both. So integration of u to v is equal to dv by under root v and 0 to t minus k. What is the equation for that? Integration of 1 by root v dv. So we know that it becomes v1 half minus, if we integrate this, become what become? V power minus 1 half plus 1 divided by minus 1 half plus 1. So it becomes v 1 half divided by half. And opposite is very simple. So v 1 half by 1 half. So 2 it should be outside, and then minus kt. It is very simple now. V power 1 half, 2 should be outside, so it gives upper side minus kt, and our solution is somewhere here. So at v is equal to 0, right, because it is mentioned that finally come to rest. So v is equal to 0, put the v is equal to 0 and t is equal to, if you simplify this equation, become 2 root u divided by k. Oh, first answer we got. Now next, find the distance the particle travels during this time. We need distance. Now we need, see, we got one equation for velocity. Now we need distance. So we know that a is equal to dv by dx, and that equation we already gone through this. dv by dt is equal to dv divided by dx. dx by dt is equal to v. So we can write v. This equation becomes v dv by dx. The similar equation it is here mentioned. So v is acceleration is equal to v dv by dx, because here we need distance, and therefore it should not be t. This should not be t. It should be x. Put equal to v by v multiplied by dv by dx is equal to acceleration, and acceleration we have here minus k under root v. If you just put here root v, so what become? It become 1 by root t, or root 2 root v become. You can keep this k on the opposite side also, no need to move this k. Then take integration on the both the side. Taking integration on the both the side, root v that we already have, root v power 1 half integration if we are doing, so that become v power 3 by 2 divided by 3 by 2. So v power 3 by 2 divided by 3 by 2, right? So 0 to u to 0, we know that final velocity is 0 minus kx. putting this value, we can get x is equal to 2u power 3 by 2 divided by 3k. Wow, what an answer. Right, again you solve by yourself without seeing this video. Right, you may pause this at initial as well as at final. You try once again, otherwise you may have difficulties in this question. Let's go to question number 15. The velocity v of a particle moving in a straight line varies with displacement x as v. Equation is given here. V is equal to under root 9 minus x, the maximum acceleration of the particle. We saw here a velocity is given, and here in the inside it is a function of x. Velocity is a function of x. That you remember, velocity is in this equation, velocity is function of x. Fine. So velocity is given, v is equal to 9 minus x square. We know that acceleration, we need acceleration. Acceleration is equal to dv by dx. You can take this. So is equal to dv divided by dx. It is not x, but it should be t. Correct me. Dx by dt we need here, and we can write v dv by dx. Right. Now, so you can have put value of v at somewhere here, and you can differentiate also, you may get answer. But so this is one, we got it here, Now very special thing it is done here. Let me show you something. You can try, you can do differentiation also directly. There isn't any issue for that. But now if I just want to put this v inside, right, so I can do integration of v with respect to v or x, whatever it is, with respect to x or whatever. So what will become? It become v power 2 divided by 2 divided by 2. So here similar case is done. Here. Just move this velocity inside differentiation, and then become 1 half d by dx v square. If I just differentiate this, so it gives us what? 1 half multiplied by 2 v square dv by dx. So it is reverse is correct. If reverse is wrong, then only there is an issue. Do we have value for v square? Yes. V square is equal to 9 minus x. Put this value here. A is equal to 1 by differentiation. So 9 becomes 0 is equal to 1 by 2. 9 becomes 0 minus 2x. Right. See, you can do differentiation of the entire 9 minus x square, but it is difficult and you will have a difficult answer for that. That's why the simple method is good. So a become x, a become minus x, a become minus x. Right. Now we need to have a maximum acceleration. What should be value? We got here equation. But here if you see velocity equation, v is equal to under root 9 minus x square. And this term should be 9 minus x square should be greater than or equal to 0. This term should be greater or equal to 0. That means what? 9 greater or equal to x square, and therefore 9. If I just take root both the side, 3 greater or equal to x. Or you can take plus or minus. That should be, it should not cross value of 3, and it should not be less than greater than 3 plus as well as not less than minus 3. So we know that v must be real number, and therefore x power 2 is less than 9. Therefore plus or minus 3. You can put here a is equal to plus or minus 3, or you can get 3 plus or minus 3. Answer is 3. Acceleration or deceleration, retardation. It should be 3. It should be 3. So a is equal to 3. This is the correct answer. A is equal to 3. Such tricky questions you will find in NEET and JEE. That is for sure. One more question. It is here. Example number 16. I think you should pause the video and try by yourself. What is mentioned here? The acceleration of a particle moving with an initial velocity u and the equation is given. So this equation is important. If it is A, that means there is definitely going to be some kind of integration is possible. A is equal to a k under root x. It is a function of x. It is a function of x, right? Where k is constant. See, if object it is function of t, so it is very easy to do dx by dt or dv by dt. But if it is a function of x, then you need to have dx as a differentiation, right? It is difficult. So what is mentioned here, the distance covered by the particle when its velocity become u. So initial velocity was u and it become final 3u, right? So we need to find distance covered. X is required, right? So we know that this equation we know, right? A is equal to dv by dx, we can put, and dx by dt is equal to v. So we can write in this manner, right? So A is equal to what? K root x. We know that this equation A v is equal to dv by dx is equal to k root x. And what next? V dv is equal to k root x dx, taking integration both the side. Initial is u velocity, final is 3u, that is given. V du, v become v square by 2 u, 3u is equal to k is constant. What is x power? X power 1 half. So integration of x power 1 half become x power 3 by 2 divided by 3 by 2. We already did this part. We did this part. So it is here. Put the values of v is 3u and minus u. So you can say 3u square minus u square 1. So 1 become here and is equal to k 2 by 3 x power 1. So when you have it 9u square minus u square divided by 2, so it become 8 u square by 2, and you can solve it. Now it becomes very easy. So 4u square is equal to root and you can have x power 3 by 2 and you can have opposite power opposite side. So x is equal to 6 u power 2 divided by k 2 by 3. Very simple. And then, oh, question from JEE main 2019. Yes, what you should do, you should pause the video and solve this question. Example 17 is given. A particle is moving with speed v is equal to b root x along positive x-axis. Calculate the speed of particle at time t is equal to tau. T is equal to tau. Assume that particle is at origin t is equal to 0. Fine. So here v is given b root x, and we know that acceleration is equal to dv by dt. And if it is there x, always convert in this form. Right? So a is equal to dv by dt is equal to dv by dx multiplied by dx by dt. What is dx by dt? That become v. And what is dv by dx? You can see velocity is given here. So you can take dv by dt b root x. What about root x? So it is x power 1 half. If we do differentiation of this, so it gives 1 half x power minus 1 half, right? So ultimately it become 1 upon 2 root x, 1 by 2 root x. Very simple, very simple. So put here this value. So it is here b 2 root x, and this become dv, this become dv, this become velocity, this become velocity, and velocity is given. So put velocity here. Bx, x is cancel, is equal to b square by 2. Acceleration is equal to b square by 2. This is given. So calculate speed of the particle at given t is equal to 2. Assume that velocity is at its origin. So we can do dv is equal to b square by 2 dt. or we have equation from uniform. We may try, right? You may try dv by dt. So you can put t opposite side, b square by 2 dt. Just check, are you getting the answer by using that? If you get answer, comment me. So from equation of uniform, v is equal to u plus at. This is given. This is given. So here at time t is equal to 0, at time t is equal to 0, at time t is equal to 0, we have equation of velocity. We have equation of velocity. V is equal to bx at t is equal to 0. X is also 0 because it starts with origin. So v become at initial stage, this becomes 0. So initial velocity is 0. So put this here. U, here it is the similar at. You put a value of a, put value of a. We already derive a is equal to b square by 2. Put value of here a, and t is equal to tau, and t is equal to tau. At a time t is equal to tau. So v is equal to b square tau divided by 2. This is solution for that. JEE 2019. This kind of questions you will see in JEE NEET, and be ready for that if you do not want to lose marks for that. Then let's have last question for today's session. Example number 18. The question was asked in JEE Main 2019. We already solved 17 examples till the time for this kind. I think you should pause the video and you should solve this. What is given here? The position vector of particle changes with time. That is a story. It is the real is given here. R of t is equal to 15t square I. What is I? What is I? What is this I? And 4 minus 20t square j. See, I have a full session on vector, right? Everything about vector is explained, and this is coming from vector I. I is showing unit vector along x-axis, and j is showing unit vector along y-axis of the Cartesian coordinate, right? I suggest that if you have not gone through vector, then I have videos on vector. You should be having a detailed understanding of vector. Otherwise, there are chances that you may lose marks for that. So what is the magnitude? It is asked for the acceleration. We have equation of displacement, and therefore v is equal to dx by dt. If we differentiate this, so here the equation is given like that, is equal to 15t square I cap, it is x direction, plus 4 minus 20t square j direction. Let's have here. So here 15 multiplied by 2t, differentiation of this 2t, and thus keep I as it is. I is showing x direction, nothing else. Plus 4 becomes 0 minus 20 multiplied by 2t, and keep it j. Therefore, you will have this equation. You will be having this equation for that. So now we have velocity, but we need acceleration. Let's differentiate once again. So here 30t become 30, 0 is not required, 40t become 40. So 30i, 40j, acceleration is having 30i and 40j along x direction, along y direction. And here if you need magnitude a is equal to under root that 30 square plus 40 square, 30 square plus 40 square. So 30 square plus 40 square is 2500 is equal to 50 meter per second. 50 meter per second, that was asked in JEE Main 2019. So thank you very much for watching Registrar Doctor. Please do subscribe. We will definitely finish the full course with all the examples from easiest to all the difficult examples. Thank you very much for watching.